In this video, you will learn about k-means clustering algorithm and also understand its working and applications. In order to understand k-means clustering algorithm, we first need to know about unsupervised learning and clustering. Unsupervised learning is a type of machine learning in which an AI system is presented with unlabeled or uncategorized data. No labels are given to the learning algorithm. It works on its own to discover patterns and information that was previously undetected. Clustering is the process of dividing the entire data into groups or clusters based on the patterns in the data. Clustering can be defined as the task of identifying groups or clusters in the data such that data points in the same group or cluster are very similar while data points in different groups or clusters are very different. An example of that is clustering patients into different groups. K-means clustering is one of the simplest and popular unsupervised machine learning algorithms, which is used to identify clusters of data points in a dataset. It is an extensively used technique for data cluster analysis. It is much easier to understand this algorithm using scatter chart. The first step is to create k number of cluster centers and assign them random values of WGB and RGB, hence these cluster centers will be generated at random positions in the graph. These cluster centers must be uniquely labeled. The second step is an iterative process consisting of two sub-steps. Sub-step A is assigning labels to all data points in our dataset. Every data point is assigned the label of the particular cluster center which is nearest to it. Mathematically, Euclidean distance formula is applied to calculate that which cluster center is nearest to any data point. Sub-step B is recentering of cluster centers. Currently, there are 9 data points which are labeled blue. The geometric centroid of blue points will be calculated and blue cluster center will recenter itself by moving to geometric centroid of all blue points. Same goes for all other cluster centers. The geometric centroid of red points will be calculated and red cluster center will recenter itself by moving to geometric centroid of all red points. You get the idea. Now sub-step A will be repeated. As the cluster centers have been moved to new positions, data points will update their labels based on the Euclidean distances between them and the cluster centers. After that, sub-step B will be repeated. As the data points have been assigned new labels, positions of geometric centroids will also change. Hence the cluster centers will be recentered again. The repetition of substeps A and B will continue until there is no change in the positions of all cluster centers. At this stage, algorithm will be completed. There are various applications of this algorithm in the fields of genetic research, image segmentation, market research, medical imaging and social network analysis. There are some cons of this algorithm as well. Finding the optimal value of k is difficult. As the value of k increases, you need advanced versions of this algorithm to pick better values of the initial positions of cluster centers rather than assigning random values. In the next video, I will implement this algorithm using JavaScript and chart.js. Support me by liking, commenting, sharing, and don't forget to subscribe the channel. Thank you.